Craig Shallenhammer. I'm the founder and president of Orapub, and I'm a DBA just like you. So by completing my Machine Learning 1 LVC, you now have a running and working Oracle Activity Anomaly Detection System in production. Congratulations, you are in the top 2% of all Oracle professionals. But there's more. If you want to take your machine learning to the next level, then pay close attention, because this LVC is about building and deploying performance prediction systems. This class focuses on supervised machine learning algorithms, and it's a whole new world, and it's really big. More specifically, you're going to build a performance predictive system, a green, yellow, red light performance prediction system that you can hook into your existing alerting infrastructure, or you can just have it send you an email with pictures. The process to properly and ethically develop supervised machine learning models is much more complicated and involved than unsupervised models that we used in the anomaly detection system. This is especially true for us because we use primarily Oracle performance data. As I introduce the class, pay close attention to the differences between this class and the Machine Learning 1 LVC. Here's a list of some of the things that you're going to be able to do after completing this course. You will be able to understand, build, deploy, and tune your performance prediction system. Understand and use a wide variety of supervised algorithms, including decision trees, artificial neural networks, naive Bayes, dummy, naive classifiers, and others. Perform advanced label creation and analysis for proper threshold determination. Evaluate multiple supervised learning algorithms using a variety of advanced techniques. Explain how your machine learning performance prediction was developed and works. Appropriately deal with our rare event and small Oracle datasets. Determine the most powerful predictors using multiple techniques. Use the industry standard machine learning Python libraries, Jupyter notebooks, and project methodologies. And use AWR, Ash, and Sysmetric data in your machine learning models. Which is awesome because 50 to 80% of machine learning projects are never deployed. The bottom line is this. You're going to have a working Oracle performance predictive system by the end of this class, or your money back. We'll talk more about my insane guarantee a little later. Let's talk about how this LVC actually works. This LVC is structured very much like my Machine Learning 1 LVC, except there's 6 sessions, not 4, because we have a lot more to cover. And there's at least a 1-day gap between each session. There's also an optional paid bonus session. We'll be using Python, Python's machine learning libraries, and Jupyter notebooks. And again, all the Python code has been written for you, so you can focus on learning and deployment. So what about your machine learning environments? Just like with my Machine Learning 1 LVC, you will need 2 environments. The first is your learning or Sandbox environment, and the second will be your deployment environment. There is a link at the bottom of this page that will bring you to step-by-step instructions how to set up both of your environments and get them completely working and ready for the class. In fact, the first session, we spent some time ensuring that your environments are working as expected. If you have any questions about this, feel free to contact me. Now let's talk about the course contents. There are 6 sessions, and each session has a couple kind of fundamental or core objectives. Session 1 is entitled Sandbox and Development Environments Setup Workshop. We need to ensure that your sandbox and deployment environments are set up and working. And we're going to carefully walk through the supervised learning process. Now, this is very different from our unsupervised anomaly detection system process that we focused on in the Machine Learning 1 LVC. Session 2 is entitled Processes, Models, Features, and Predictions. We're going to talk about decision trees, which is one of the main supervised learning models. We're also going to talk about determining the predictive power of our models. This is an overview because in the next session, we're going to do a deep dive into this. Then we're going to dive into our project notebook, and I want to make sure that you guys can quickly evaluate multiple models, and I want you to learn how to make predictions, which is really satisfying. Session 3 is entitled Accuracy Deep Dive and Label Threshold Analysis. Now, a label is what we are trying to predict, such as green, yellow, or red. And this requires analysis and sometimes can be pretty involved. So I'm going to teach you how to do this. We also have to deal with what's called rare events because our data sets and Oracle performance should be a rare event. So Determining model predictive power is much more complicated for us and requires a deep dive into this topic. I'm also going to talk about what's called naive classifiers. Session 4 is entitled Rare Event Strategies and Artificial Neural Networks. Most supervised learning models struggle to recognize a rare event, like poor performance. I'm going to teach you a number of industry standard ways to deal with this. And we're going to talk about artificial neural networks using the TensorFlow platform that's actually built by Google, because decision trees do have some predictive limitations that artificial neural networks can sometimes overcome. Session 5 is entitled Feature Reduction and Incorporating ASH Data. Usually less predictors are better than more. And so I'm going to teach you a number of industry standard ways to identify the best predictors. Then we're going to talk about a model called the naive Bayes classifier, and we're going to get into integrating ASH data into our project. And this requires some special processing that naturally leads us into some of the more important machine learning topics, such as one-hot encoding. Session 6 is entitled Tuning, Alerting, and Deployment Operations. Like any Oracle database, every machine learning model has parameters we can alter to improve its predictive power. So I'm going to show you how to discover the optimal parameters for your data sets. Also, it's time to integrate any poor performing alert strategies into our model so we can communicate issues with the outside world. And also, there are some important deployment operations we will need to discuss that are unique to supervised models and our predictive system. The optional bonus session is entitled Overcoming Deployment Realities with Solutions and Tips. You will have questions about your systems that you would have not known about or even cared about during the class. So this is why I created this optional but paid session. In the bonus session, what I do is I take all your questions and comments and I basically create a custom session just for the students. It's a great way to talk about the realities of deployment that we're just not ready to talk about during the core course. This is an optional but paid session to keep the core cost lower. So that's the class in a nutshell. Registering for any class comes with some risk. So to help reduce your risk to just about zero, I created this insane money back guarantee. So here it is. If you attend all the sessions live or recorded and follow the steps I teach you and do the homework and ask me for help, then you will be able to build industry standard machine learning environments in Windows, Linux, or OS X within 30 minutes. Deploy your machine learning performance predictive system, use industry standard machine learning libraries and Juniper notebooks, explain how your machine learning performance predictive system was developed and works, and explain how performance prediction fits into a broader and existing monitor and alerting strategy. If you cannot do all of these skills within 2 weeks after our last session, ask me for a full refund and you will be refunded in full. Now that's a real guarantee. So if you want to take your machine learning skills to a whole new level, build high accuracy performance predictive systems using supervised learning, and be able to say, I have a deployed supervised learning performance predictive system in production, then this class is for you. If you have any questions, please contact me. I look forward to seeing you in my next Machine Learning 2 LVC.